After decades of research, construction, and a Christmas Day launch, we are getting more full-color images from the James Webb Space Telescope.
The first faint detection came as a whisper in the data streams of the James Webb Space Telescope, a flicker of light where none should have been. Astronomers had turned their gaze toward 3I Atlas, the third known interstellar object to pass through our solar system after the enigmatic Wanan, Oumuamua, and Tua/Borisov. This particular visitor had been cataloged and monitored carefully, its unusual trajectory suggesting an origin far outside the realm of familiar comets and asteroids. When Webb's sensitive instruments probed its passing silhouette, researchers expected cold reflection, starlight bouncing off an icy or rocky surface. Instead, what they found defied conventional astrophysics. The signature resembled artificial illumination, light emitted with patterns and intensities inconsistent with any natural reflection. Before we start, smash the like and subscribe buttons for more updates. At first, skepticism reigned. Cosmic rays, striking detectors, instrumental noise, or an unrecognized atmospheric effect could all masquerade as anomalous brightness. But the Webb team had spent decades preparing for precision at levels unthinkable before. When the data were reprocessed, scrubbed of interference, and compared across multiple observation windows, the strange glow remained. It was not the diffuse scattering of sunlight across an icy shell, nor the sharp reflection of metal-like minerals. The spectrum suggested narrowband emissions, as though generated by deliberate design. The very idea unsettled scientists. Light, particularly in coherent and modulated forms, has long been theorized as one of the best signals of intelligence. For centuries, humanity has beamed radio waves into the cosmos, then turned ears to the sky, hoping to hear them echo back. Yet here, drifting silently through the solar system, was a body that appeared to carry its own beacon. Unlike radio transmissions, which spread thin over distance, the glow from 3Y Atlas was localized. It shimmered with consistency. Unlike the erratic glints of tumbling rocks, it bore hallmarks of structure. The implications struck at the heart of one of humanity's oldest questions. Was this an accidental byproduct of alien engineering? Perhaps the remains of some automated probe still running long after its creators vanished? Or was it intentional? A deliberate lighthouse cast into the darkness of interstellar space. The Webb's instruments, sensitive enough to dissect the faintest signatures of atmospheres around distant exoplanets, now provided humanity its first potential glimpse of extraterrestrial technology in situ. Astronomers argued over the possibilities. Some suggested that what appeared as artificial light could be a kind of fluorescence triggered by solar radiation interacting with unusual compounds. Others countered that the patterns repeated with too much precision. Peaks and troughs in the emission lined up like the cadence of circuitry, like engineered pulses. Such an interpretation suggested intelligence on a scale humans had never encountered. As news spread through scientific circles, secrecy was abandoned in favor of peer review. Data packets circulated between observatories, each testing the finding against their own models. Ground-based telescopes with adaptive optics sought corroboration, though none could match Webb's clarity. Slowly, consensus formed. Whatever was emanating from 3Y Atlas could not be explained by ordinary natural processes known in the catalog of cometary science. It was too clean, too deliberate, and too persistent. The sheer improbability of it heightened the wonder. Interstellar objects are rare. The fact that one wandered close enough for Webb to examine with precision was extraordinary. The additional fact that it showed signs of artificial light bordered on the miraculous. The universe seemed suddenly alive in ways more direct and immediate than ever before. For decades, the search for extraterrestrial intelligence had been haunted by silence. Now, a rock from between the stars had whispered back. Theorists began to construct scenarios. One camp proposed that 3Y Atlas might be a derelict craft, ancient beyond reckoning, drifting across galactic distances. Its light could be an energy source still sputtering like an old nuclear battery that refused to die. Others envisioned a purposeful design, a probe seated to wander, its glow a homing signal. The scale of time involved, tens of thousands, even millions of years of travel, suggested creators with an entirely different perception of patience. Debates turned to purpose. If artificial, was the light meant for communication, navigation, or concealment? Light is an inefficient medium to shout across the cosmos. Yet as a short-range beacon it excels, guiding encounters in dark space. Could 3i Atlas have been a kind of cosmic breadcrumb, a waypoint in an interstellar network? Or perhaps it was not meant for us at all, but for others, an artifact lost or intentionally left behind in the drifting lanes between stars. The Webb detection, carefully calibrated and independently confirmed, transformed a simple astronomical curiosity into something more profound. Humanity now faced an object not just of interstellar origin, but potentially of intelligent origin. Philosophers, scientists, and even policymakers were drawn into the conversation. If the light was artificial, it signaled that intelligence had bloomed elsewhere. This was not a question of probability anymore, but of evidence. The narrative of discovery echoed ancient tales of beacons on the sea, lighthouses guiding ships to safe harbor, or warning of hidden rocks. For our species adrift in the immensity of space, the glow from 3i Atlas resembled such a signal. It spoke to possibility, that we are not alone, that the long silence might not be emptiness but distance, and that across those gulfs others too had reached out in their own way. The raw awe of it spread across the scientific community. Astronomers spoke with careful precision, aware of the need for skepticism. Yet the wonder in their words was palpable. The James Webb Space Telescope had been built to glimpse the faintest galaxies from the dawn of time. That it might also glimpse proof of intelligence from beyond was an unexpected gift, one that shook the boundaries of science and imagination alike. In the absence of definitive proof, the event galvanized new research. Future missions to monitor interstellar visitors were proposed, dedicated instruments designed to catch the brief windows when these travelers entered our reach. For the first time, the search for life beyond Earth had a tangible target, something closer and more immediate than distant exoplanets hidden behind stellar glare. Each fragment of data was pored over, each curve in the light spectrum studied like scripture. Specialists in optics, astrophysics, engineering, and information theory all brought their perspectives. Some argued for modulation patterns in the emissions, hints of encoding that might represent information. Others cautioned against anthropomorphizing noise. The debate was intense, yet unified by the recognition that something extraordinary had been observed. Beyond science, the cultural resonance of the discovery was immense. The idea that artificial lights had been detected on an interstellar body struck a chord with human imagination. It tapped into archetypes of ancient contact, messengers, and wanderers from beyond. Artists, writers, and thinkers found in it inspiration, weaving the Webb detection into a tapestry of possibility. Humanity's long dream of other minds among the stars seemed suddenly closer, shimmering faintly just beyond reach. The very distance of 3i Atlas added to its mystique. Here was a visitor not from the solar system, not bound to our sun, but a messenger from another star. That its surface seemed alive with artificial light meant its story did not belong to geology alone, but to civilization. It suggested that somewhere, once or still, there existed beings capable of technology. Beings who had touched this fragment before it came to us. The James Webb Space Telescope, with its golden mirrors and infrared gaze, had pierced the veil of distance not only to glimpse the earliest galaxies, but to catch perhaps the faint signature of intelligence itself. That one instrument could bridge such extremes, cosmic birth and possible alien artifact, was a triumph beyond measure. The lights on 3i Atlas might be faint, uncertain, and fleeting, but they represented a threshold. A door had opened, however slightly, and humanity found itself staring through into a larger cosmos. As the weeks unfolded, every telescope turned toward the interstellar traveler. Amateur astronomers sought glimpses, though few could detect what Webb had seen. Agencies prepared observation schedules, eager to maximize the brief window before the object slipped back into the depths. The glow became a symbol, a fragile yet persistent reminder that the universe might not be as silent as it once seemed. For scientists, it was both a challenge and a gift. The challenge lay in verification, in the rigor of separating fact from error, of not leaping too quickly into extraordinary claims. The gift lay in the data itself, in the rare chance to study something possibly created beyond Earth. Even if the lights proved to have a natural explanation, the exploration had already pushed humanity further, forced new questions, and rekindled the wonder that drives discovery. If the glow truly is artificial, then 3I Atlas is more than an interstellar rock. It is a message, intentional or not, reminding us that the stars are not empty. Its light becomes a conversation starter across generations, a spark igniting both science and imagination. The Webb detection ensures that humanity will look at every future interstellar visitor with sharpened curiosity, ready to find echoes of intelligence in the shadows of the unknown. The telescope's findings have thus reshaped how we view cosmic wanderers. Once seen as curiosities, they now stand as possible emissaries. With each passing observation, the lines between astronomy and archaeology blur, for to study 3I Atlas may be to study the handiwork of a civilization far older and perhaps far wiser than our own. The light captured by Webb is more than data. It is a bridge between worlds, an invitation to consider that intelligence may not be confined to Earth, but may drift among the stars, waiting to be found by those who dare to look. The signal from 3Y Atlas marked not only an astronomical observation, but a profound shift in how humanity perceives its place in the cosmos. The James Webb Space Telescope, a marvel of engineering designed to peer across time and space, had given us many surprises since its launch. But none approached the weight of this discovery. What was supposed to be another interstellar visitor to catalog, study, and perhaps compare with Oumuamua and Borisov, became a puzzle stretching the very boundaries of imagination. Artificial light on an interstellar body was not an extension of natural processes. It was the mark of intent, of design, of civilization. From the very beginning, the analysis of the glow demanded interdisciplinary collaboration. Astronomers contributed expertise in light curves, planetary scientists modeled surface reflectivity, engineers reconstructed what technologies could generate such emission, and anthropologists speculated on what motivations might drive an alien civilization to send out illuminated objects into the interstellar void. No single discipline could hold the weight of the questions raised. Each brought a fragment of understanding, piecing together a mosaic that was larger than any field had ever been asked to assemble. In its rawest sense, artificial light requires energy. Energy, in turn, requires a source, whether chemical, nuclear, or something more exotic. If the glow of 3Y Atlas came from a power system, then it implied machinery. Machinery suggested construction, and construction revealed a civilization with not only the capacity to design, but also to launch. For the first time, the conversation shifted from the speculative, "Are we alone?" to the tangible. What technologies did they have, and how far ahead of us were they? One model proposed that the light represented a decaying nuclear battery. Certain isotopes, if harnessed, could glow steadily for thousands of years. To our species, such endurance already seemed astonishing, but when viewed on galactic scales, even millennia were fleeting. Others considered the possibility of a system more advanced than anything humanity had yet imagined: antimatter reactions, dark matter interactions, or energy harvested directly from the quantum vacuum. Each possibility underscored the fact that intelligence capable of harnessing interstellar scale technology existed somewhere beyond our world. As the data poured in, theories multiplied. Some experts argued the light was structured in narrow spectral bands not typically associated with chemical reactions. This raised the possibility of encoded information, a kind of cosmic Morse code embedded in the brightness itself. If true, then the glow was not just a beacon but a message, though one we had only just begun to translate. Decoding such a signal would require years, perhaps decades, of careful analysis. But the idea that meaning itself might be hidden within the spectrum electrified the scientific community. The philosophical implications were equally staggering. For centuries, civilizations on Earth debated whether the universe teemed with life or whether humanity was unique. The faint glow of 3I Atlas tilted that debate decisively. If artificial, then we were not a singular phenomenon but one expression among many. The Copernican principle, that Earth was not the center of creation, extended once again, reminding us that our civilization was not alone at the pinnacle of intelligence. There were others, or at least there had been. The detection forced thinkers to grapple with scales of time. Interstellar travel, even for a tiny fragment of rock, required millions of years of wandering. If 3I Atlas carried artificial light, then its creators might no longer exist. Their civilization could have flourished and fallen eons before humans first struck fire from stone. Yet their artifact endured, a ghost drifting across the galaxy, carrying evidence of their mastery into futures they could not have foreseen. That endurance in itself became part of the wonder. It was not just a light, but a testimony across epochs. In cultural spheres, the story of 3I Atlas spread like wildfire. Writers compared it to myths of Prometheus, bringing fire from the heavens. Artists rendered paintings of a lonely glowing shard crossing the solar system, a silent emissary from the stars. Musicians composed symphonies inspired by its light curve, treating the brightness as notes in an otherworldly melody. What Webb had seen transcended science. It reached into the collective unconscious, rekindling the dream that humanity might one day step out into the galaxy and find others waiting. Governments, too, could not ignore the discovery. Artificial light implied technology, and technology implied knowledge that might be harnessed. Agencies debated whether missions should be rushed to intercept the object. Could a probe be launched in time to rendezvous before 3I Atlas slipped back into interstellar space? The logistics were daunting, yet the desire was immense. Capturing even fragments of an artifact of alien origin would represent the greatest leap in scientific history. It would transform engineering, physics, and perhaps even culture itself. Religious and philosophical communities found themselves wrestling with questions as ancient as belief itself. If artificial light truly emanated from an alien construct, what did it mean for humanity's spiritual place in the cosmos? For some traditions, it was a confirmation of creation's vastness, a sign that intelligence blossomed wherever conditions allowed. For others, it provoked unease, challenging doctrines of uniqueness. But whether embraced or resisted, the discovery demanded response. It could not be ignored. Among the most compelling discussions centered on motivation. Why would an extraterrestrial civilization send such an object into interstellar space? Was it exploration? A probe designed to wander and report? Was it art? A cosmic sculpture lit to inspire any who found it? Was it defense? A sentinel monitoring the void? Or was it accident? The drift of a vessel long abandoned yet still carrying the light of its makers. Each scenario revealed different facets of possible alien psychology, none of which humanity could yet confirm, but all of which were contemplated with fervor. The raw emotional impact of the Webb detection rippled through society. For generations, humanity had stared into the night sky and imagined neighbors among the stars. Now, for the first time, data suggested their presence not in distant radio static, but in a tangible object passing within our reach. The universe no longer seemed vast and indifferent. It seemed populated, intentional, threaded with intelligence. The silence that had haunted the search for extraterrestrial life gave way to a faint, glowing response. At the same time, caution tempered excitement. Scientists insisted that extraordinary claims demanded extraordinary evidence. They scrutinized Webb's calibration, checked its detectors for anomalies, and reran every analysis. The persistence of the light signature across multiple observation windows became the foundation of confidence. Still, the need for verification meant that humanity lingered at the threshold of certainty, caught between wonder and rigor. For those directly involved in the discovery, the experience was transformative. Astronomers accustomed to parsing faint smudges of light across unimaginable distances now found themselves confronting data that might reveal intelligence. The responsibility weighed heavily. Each publication, each statement had to balance possibility with discipline. They knew that their work would not only echo in scientific journals, but also in history books and classrooms for generations to come. The cultural imagination soared further. People asked whether 3I Atlas might be a scout, the first of many, or whether Earth itself had been noticed. While Webb saw only light, speculation filled the silence with stories. Some envisioned a galactic archive, fragments sent into the void to carry knowledge across eons. Others feared darker scenarios, warning that such objects might be markers left by civilizations less benign. The spectrum of interpretation revealed more about humanity's hopes and fears than about the object itself, yet all traced back to that single point of data: artificial light. Technologists proposed ways to extend the investigation. Could Earth-based lasers be fired at 3Y Atlas, pulsing in universal mathematical sequences, to test if the object responded? Could radar reveal structural details? These ideas, though ambitious, represented the desire not just to observe but to engage. If the glow represented intelligence, then humanity faced the first tentative steps of dialogue, though one separated by incomprehensible gulfs of distance, time, and culture. For those focused on deep time, the event was humbling. Civilizations might rise and fall, yet artifacts could endure. Just as Earth carried fossils from ages past, the galaxy might carry technological fossils from civilizations long gone. 3i Atlas with its strange glow could be such a relic. It was a reminder that while life is fleeting, creation can outlast its makers, whispering across epochs to anyone prepared to listen. Scientists began to reevaluate the rarity of interstellar visitors. If one out of the first 3 known carried signs of intelligence, did that mean such artifacts were common? Perhaps the galaxy was seeded with them, each a silent traveler crossing systems, waiting for curious eyes to take notice. This possibility recast the search for interstellar objects not as mere astronomical curiosity, but as an archaeological endeavor on a galactic scale. The sky itself became a museum, and Webb its first great curator. The implications reached into education too. Students around the world, hearing of artificial light from another star system, felt their sense of possibility expand. Entire generations might grow up assuming not solitude but plurality. That intelligence was a cosmic phenomenon rather than a terrestrial anomaly. The seeds planted by 3i Atlas promised to influence the trajectory of science, exploration, and even the arts for centuries to come. For engineers designing humanity's own spacecraft, the discovery carried practical lessons. If alien technology could endure interstellar travel, then human technology might one day aspire to the same. The very existence of a glowing artifact among the stars became both challenge and inspiration, urging humanity to look not just inward but outward, to design for endurance, and to imagine futures that stretch not decades but millennia. The story of Webb and 3i Atlas thus intertwined science and symbolism. On one level, it was a technical observation of light curves and spectra. On another, it was the first tangible evidence that intelligence might not be confined to Earth. The 2 levels could not be separated. The data was inseparable from the awe it evoked. The glow was more than photons. It was possibility. As more instruments joined the observation campaign, subtle variations in the light emerged. These flickers tantalized researchers, hinting at complexity. Could rotation explain them, or were they signatures of a mechanism adjusting its output? Each possibility carried weight, and each added another layer of intrigue. Humanity had always sought patterns in the stars. Now it sought patterns in a light that might carry intention. Even as 3i Atlas prepared to slip from the solar system, its legacy had already taken root. Future telescopes would be designed with interstellar objects in mind, missions would be proposed to intercept them, and theories of life in the universe would incorporate the possibility of technological artifacts drifting through the void. The discovery marked not an end but a beginning, a spark that ignited new trajectories of thought and exploration. The artificial light from 3i Atlas, captured by the James Webb Space Telescope, was more than a scientific anomaly. It was a threshold moment, a glimpse of something greater, a reminder that the universe is not static but filled with wonders waiting to be found. Whether relic, beacon, or message, the glow affirmed that humanity's search for company among the stars had not been in vain. And though answers remained elusive, the very act of detection transformed our understanding. The cosmos was no longer silent. It shimmered, faintly but undeniably, with the light of possibility. The glow of 3i Atlas, captured in the meticulous data of the James Webb Space Telescope, did not merely trigger scientific excitement, it fractured the boundaries between what was once theoretical and what could now be considered empirical. Until that moment, the conversation about extraterrestrial intelligence was mostly grounded in probabilities and paradoxes. The famous question of Enrico Fermi, "Where is everybody?" had haunted scientists for generations. The Webb detection, however faint or fleeting, provided the first possible counterpoint to the silence. It suggested that everybody might not be absent at all, but hidden in plain sight within the passing of interstellar fragments. The shift in paradigm was not just about the existence of other civilizations, but about how intelligence might manifest across cosmic scales. For centuries, humanity assumed that intelligent life, if it existed, would reveal itself through communication, radio waves, signals, or messages crafted for discovery. 3i Atlas challenged this expectation. Here was not a broadcast, but a beacon, not words but light, an object that carried the hint of design without explanation. It broadened the scope of the search for extraterrestrial intelligence beyond listening and toward observing, beyond signals and toward artifacts. Scientists coined new terms to describe this form of inquiry: interstellar archaeology, technosignature by proxy, and even cosmic forensics. Each reflected the idea that intelligence might be discovered not in dialogue, but in remnants, the way archaeologists on Earth reconstruct civilizations long gone through ruins and relics. The artificial light on 3i Atlas thus stood as a shard of evidence in the greatest excavation ever imagined, one stretching across galaxies and epochs. This expansion of perspective carried profound implications for the way humanity might one day detect other forms of life. Instead of waiting for radio signals that may never arrive, telescopes could hunt for anomalies in light, heat, or structure across the sky. The Webb detection became a proof of concept. Intelligence might reveal itself in subtle ways, requiring only the right tools and attention to notice. That realization galvanized research in technosignature detection, inspiring proposals to analyze every oddity in astronomical surveys for traces of deliberate design. Meanwhile, in the cultural sphere, the story of 3i Atlas transformed into metaphor. It became a symbol of the encounter between the known and the unknown, a reminder that the universe might be layered with meaning beyond comprehension. Writers spoke of it as a lighthouse in the dark sea of space, while philosophers described it as a mirror reflecting humanity's longing for companionship. Even skeptics, who doubted the artificial interpretation, admitted that the event reinvigorated curiosity, drawing millions into conversations about the stars. Beyond metaphor, the discovery carried practical urgency. The window of opportunity to study interstellar visitors is fleeting. These objects race through the solar system at extraordinary speeds, and by the time they are detected, they are often already on their way out. 3i Atlas underscored the need for preparedness. Rapid response missions capable of intercepting interstellar bodies, telescopes with specialized sensors trained on their trajectories, and international coordination to seize rare opportunities. Suddenly, what had seemed like academic luxuries became necessities, spurred by the possibility that the next visitor might carry not just light, but clearer evidence of intelligence. The implications for astrophysics were also profound. If 3i Atlas did indeed bear artificial light, it challenged assumptions about what interstellar space contained. It suggested that civilizations might seed the galaxy with emissaries, intentionally or not. This possibility raised a staggering question. How many such objects might exist, quietly drifting through the void, waiting to be discovered? Could the galaxy be filled with ancient wayfarers, technological fossils marking the paths of civilizations across time? The universe, once imagined as silent, now appeared as a vast archive. In political arenas, the detection sparked debates about ownership and responsibility. If an object bearing signs of intelligence entered the solar system, who had the right to study it, to probe it, or to attempt communication? Was it a matter of national interest, international cooperation, or even a moral responsibility shared by all of humanity? Some argued that such discoveries belong to all people, transcending borders and ideologies. Others, wary of technological advantage, pressed for secrecy and control. The Webb detection thus forced governments to grapple with ethical and geopolitical dilemmas unprecedented in scope. For ordinary people, the glow of 3i Atlas was not an abstract matter of policy or data. It was a reminder of wonder, of the mystery still present in the night sky. Children gazed upward with new curiosity, asking parents whether aliens truly existed. Educators found themselves reworking lessons, weaving the story into science classes as a living example of discovery. The narrative entered popular culture in ways both profound and playful, appearing in novels, films, and even casual conversations. The idea that something artificial had been detected among the stars gave tangible form to humanity's oldest dream. One of the most striking aspects of the detection was how it reframed humanity's technological ambitions. If alien civilizations could launch objects that survived journeys of millions of years, why couldn't we? The discovery encouraged engineers and futurists to think beyond immediate timescales, to design spacecraft capable of surviving interstellar travel. It reignited discussions about long-duration missions, autonomous probes, and the possibility of humanity leaving its own beacons scattered across the galaxy. 3. Atlas was not only a subject of study, but also a model, an inspiration for what our species might one day achieve. The ethical questions deepened as well. If the glow was artificial, did it constitute communication? If so, how should humanity respond? There were those who warned against any attempt to signal back, citing the dangers of revealing ourselves to unknown intelligences. Others argued that silence was impossible. Our existence was already evident through the radio waves we had leaked into space for decades. The debate became a reflection of human hopes and fears, balancing the desire for connection with the instinct for caution. Even the sciences of information theory and linguistics became involved. Researchers wondered whether the patterns in the light curve could encode data, perhaps a universal language grounded in mathematics. Just as ancient scripts on Earth were deciphered through the discovery of bilingual inscriptions, perhaps the light of 3 Atlas was a Rosetta Stone waiting to be decoded. The possibility that meaning itself had traveled across the galaxy, embedded in photons, electrified the intellectual community. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on James Webb detecting artificial lights on 3 Atlas? We want to hear from you. Thank you for watching and see you next time.